Am I audible?
Yes, sir.
Okay, thank you.
Yes, sir. Audible, sir.
Yeah. Okay, fine. In the last class, we were discussing about different types of networks, right? And in today's class, we will discuss the ISO or OSI reference model. And if time permits, I will just introduce the TCP/IP model. Fine. Okay. The first one is ISO OSI reference model, today's agenda, and if time permits, I will introduce the TCP/IP model. So whenever say the ISO or OSI reference model, right? The first in our mind comes, what is this OSI model, right? So the ISO is for International Standard Organization. International Standard Organizations, where the group of scientists along with the industry people, they will standardize the different protocols, right, in the worldwide, especially for the communication related protocols, right? So here we are having the OSI. So what is this OSI model? What is the OSI model? OSI model or OSI stands for the open interconnection. OSI stands for open system interconnection, which is used for making two devices to interact with them, right? And this was developed in 1980s, right? So this they call the conceptual model, and the used for network communications, right? So the main objective of this conceptual model is to make two devices. For example, say this is the one device and the other one is this. So I'll name it as A, and this was B. So in the 1980s, they developed a standardization of the standard reference model in order to make these two devices C and B to communicate with each other, right? So this standard has the 7 different layers, or OSI reference reference model has 7 different layers, right? So I will first list out the all the 7 layers, then one by one in detail I will explain it. The topmost layer, that the 7th layer, we call the application layer, where we usually have the user interface is there, right now whatever we are seeing in our screen in your laptop or in your mobile phone. So this is the application layer, right? And the 6th one is the presentation layer. So in the presentation layer, so data formatting or encoding, like converting from readable to non-readable form, then again decrypting, so not readable form into readable form, right? Or compression of the some images. So all these functions will be done in the presentation layer. And the 5th one is the session layer, right? Suppose you want to send a message from A to B. So we need to, at the very first, what we need to do, we have to initiate the session. We have to make an environment in such a way that A and B easily they can communicate with each other, right? So that functionalities will be taken care by the session layer. And the fourth one is very important one, and we call this is the heart of the OSI layer. So that is the transport layer, right? So here the message segmentation or reassembling, right? And providing the connection oriented and connectionless oriented services. We usually call the reliable services, right? Connection oriented and connectionless and reliable. So the all these services depending upon the again the application, right? So all these functionalities will be defined in the transport layer. The third one, this is the again very important one, the network layer. Suppose you want to communicate from one network to the another network. So suppose this is the one network, right? So this is the network A. Say for example, here is there. So this is the network A, right? And this is the network B. Correct. So network A and network B. So whenever you want to make a communication between the networks, then we need the network layer, or else we don't need any network layer if you are communicating within the network A or within the network B, right? So there we will come into picture the IP addressing and all. So that part we will be looking in this network layer, and the routing from the from one network to the another network. So I have considered only two networks. Just think of the in real time, right? So I'm in the Vellore and you people are in the different cities, right? So how whatever I'm speaking, how it is routing this information to your or laptop or your mobile phone, correct? So all this information we will be discussing in the network layer. And the second one is data link layer. Data link layer. So this is like within the network. So within this network, and if you don't have the network, I say in previous, right, when I was explaining about the network layer, I said within the network we no need the network layer, correct? So then what we need? So we have to point out. So here one PC is there, right? One desktop is there. What about the multiple huge number of desktop is there? So how to identify those desktops, right? So what to do if any errors are there? So how to rectify those errors? Correct. So all these functionalities will be taken care by the data link layer. Right. So here again we have the one more addressing called the physical addressing or MAC address. Right. So about that we will be discussing in the data link. Even we do the flow control and the error control as well in this layer. And the last one is the physical layer. The main responsibility of the physical layer is the first one is connecting the devices, right? One device C and device B is connecting. So through the link, right? RS2, 32 or the Ethernet, whatever we use, right? So that is the one. And the transmission of the physical bit, right? Transmission of physical bits. So all this will be taken care in this layer, physical layer, correct? So now we are having the total 7 layers. Now we will see one by one. So before going there, I will just give you the some more information about these 7 layers. So this uh, yeah, okay, it's not working. A minute. So these three layers are there, right? Application, presentation, and the session layers, correct? So these three layers we call the software layers. What we call these layers? We call the software layers. These layers called software because these will be there in the OS, operating systems, correct? And the one, the transport layer, so this we call the heart of the heart of OSI model, right? This we call the heart of the OSI model. And the remaining three layers, right? Network layer, data link layer, and the physical layers. So these three layers we call the hardware, right? So we will see why we call the software layers, why heart of OSI is the transport layer, why hardware layers are the network, data link, and the physical layer in the next, right? So we'll see the very first one, the physical layer. Physical layers, I'll just highlight so that everybody can see easily. Good. So this physical layer is the, as we have seen in the above, the physical layer is the bottommost layer of the OSI reference model, correct? And I have mentioned just now that it is responsible for the actual physical connection between the devices or nodes. Devices or nodes, right? So just now I gave the one example, right? So two systems are there. So its main responsible is to connect these two, right? So its main responsible or its main function is to physical connection between the device A and B. Sorry, little delay will be there. Please bear with me, right? So the physical layer main responsibility is to physically connect the device A and B or the many other devices, right? So here in the physical layer, right, it contains information, whatever the information, whatever I'm speaking, right? So this is the actual English, correct? And the laptop or your mobile phone understands its own language, right? Machine language, correct? And whenever from our laptop through modem, right, whatever it goes in terms of the bits, so that again that bits will be in the terms of analog waveform, either digital or the analog, correct? So when we speak in the physical layer, so the information contains in the form of bits, okay, very important, zeros or ones, zeros and ones format, okay, fine. Then it is responsible for transmitting the individual bits from one node to the next, right? Or one device, you can say. Here I'm using the two devices. So transmitting the bits from device A to the device B. Right? So the one is the connecting, the second one is the transmitting the bits zeros and ones. Right. So when receiving data, so this layer will get the signal received and it will convert it into zeros and ones, right, and send them to the data link layer, which will put the frame back together. And so suppose if you are thinking it is a sender, right, and this guy is a receiver. So whatever the information will come from the application layer, then presentation, session, transport, right, network, data link layer, in terms of the zeros, one, like this will come, correct? So that is a O, 0, 1, 0, 1, 0, 1, 0, like this will come, right? So when we will put in this link, right? So there little changes will be there, correct? Maybe some signal in terms of the signals will be there. So I cannot draw here. So here the in terms of the signals will be there, and the same signals again we will be converting back at the receiver. So whatever the signal is there here, so the I'll write here. Yeah, yes, signals will be there, right? Analog or a digital signals will be there. So the receiver will receive that signal and it will again convert it back into the zeros and ones, and it will put it into its frame format, correct? So the main functions in the physical layer, the very first one is the bit synchronization. Synchronization, right? So in the physical layer, provides the this bit synchronization, right, by providing a clock, and this clock, what it does is it will controls the both sender and the receiver, so that it can easily provide the synchronization at the bit level, and actually they will use the some extra information, right, at the starting and at the end. So that's how they will differentiate the different bits, and they can easily synchronize the bits as well. And the second one is the bit rate. So the physical layer, it will define the transmission rates, right? So the sender is there, and it has to send a certain amount of data to the receiver, right? And that certain amount, how to decide that certain amount, that depends upon this link, the data rate. So actually how much is the bandwidth it is. So depending on that only, the sender will decide the rate at which the data has to flow from this port to this port, right, through the medium. So that decision will be taken care in the physical layer. So that we call the bit rate control. And the third one is this, the physical topologies, right? So the devices should, in which fashion or in which what you call the arrangement should be. For example, the bus topology should be, or ring, or star, or mesh, or hybrid. So that also will be done in the physical layer. And very important one is the transmission modes, right? Transmission modes. So in the physical layer, right, it will define the data in which, or the data between the two devices, in which way this data need to be flow from the sender to the receiver. So here actually we have the three modes. So the very first one is simplex. Simplex, right? So, yeah, I'll give an example so that you will understand very clearly. Suppose three devices are there. right? Like these three devices are there, and one more device is there. So one more device is there, right? So the communication establishment will be only in this direction, only from this system to the opposite systems. Sorry. Yeah. So like this, only in one directions. For example, you can say the your keypad. So we are entering, right? So the only input it will take, or your mouse, only it will take the input, right? Or it won't give it back to you, correct? So that is the simplex. So only in this direction. And the second one is half duplex, right? So first this guy will send the data, then it will wait, then second this guy will wait, this guy will send the data to this, and similarly this guy has already sent and it will wait, then next turn is this guy, and this guy has sent, then second turn is this guy, right? So for example, you might have seen the walkie-talkie in our campus, right? Or the police guy at the traffic control, or the at the signals where it is there, there he'll be using the walkie-talkie. So there's an example for the half duplex. So one at a time they can speak. And the third one is the full duplex. So full duplex means, so at a time you can talk with each other at a time. So no need to wait for the completion of the other person to finish his talk, right? For example, in your mobile phone, right? So right now whatever we are having, this is also the full duplex. Anybody can speak right now, right? Unmute and they can speak. So this kind of communication or the transmission modes called the full duplex, correct? So where exactly the physical layer should be there in real time? That is the question. Right? We can see physical layer in the devices like hub, router, or modem, and cables. So these are the examples where the physical layer will be available. Right? So this is about the physical layer. So next we'll start the next layer, the data link. Uh, Let me make it bold and increase the font. Good. So the second most layer and the very important one is the data link layer. So its main responsible or its main role is to deliver the packet between the nodes. So we call this as the node to node delivery of the packet, or you can say packet. I don't want to use here, node to node delivery of the information, right? So then this we call the data link layer. So, and one of the main function of this layer is to make the data which we have transferred, right, is a error free from one node to another node. Whatever the data we will be sending over the physical layer, correct? So this example is the right. So I'll take that as the one. Yeah, this is the example, right? Yeah. So in this, so and if you consider this as the complete First I will select this one, make a group, and I'll enlarge it and consider as this as a one network. So as I'm speaking in the network, I mean data link layer, so it should be in the network, one particular network. Say for example, network A. So I'm in the network A, and this is the sender and the receiver and sending data, right? So here the main responsibility of the data link layer is, so whatever the data it has received from the upper layer, right? Upper layer of the data link layer is what? The network layer, right? The third one, network layer. So whatever the data it has received, so that data need to be transmitted to the physical layer, correct? And whenever we do this functionalities, so the data which has come from the network layer to the data link layer, whether the data which has received from the network layer, whether those data are error free or not, right? So that function need to be done here, right? Error free or not in the nodes in the network. So this is very important, error free or not between the nodes. So from node A or S to R. So whenever I send, when this data, so for example this is the one, right? Data I am, suppose this is the 0 here, right? Whatever the I have sent the data 0 1 0 1 0 1 double 0 is the actual data, but I am receiving the 0 1 0 1 0 1 0 1. So there is a error here. So instead of 0, here it is a 1. So detecting this kind of errors will be done in the data link layer. Okay, detecting and later correction, everything is done in the data link layer. Good. So when a packet arrives in a network, so it's main responsibility of data link layer to transmit into the host using the MAC address, right? So we don't know this. This is the device and where to send. The information has reached here. So how to identify this device? So I should know, right, your name to call you, correct? So ABC is the name. So in order to assign that name, right? So we use the one name called the media access control address, MAC address. So it's is responsibility, MAC address, correct? So these are the very important functions. And in the data link layer, DLL, in the data link layer, right? So this data link layer is divided into two sub layers. Very important these sub layers are, and each of them will give very meaningful informations. So one is, the first one is the logical link control. Logical link control. So what is this logical link control? Just now I said here, if there is the data which is sent, the 01010100 and received with a error. So detecting these kind of errors and correcting these errors, right, and forwarding to the next node. So all these functionalities will be defined in the logical link control. And the second one I can write here, even you can write error detection control is the one of the function. And the very important one is the second one, the media access control, MAC, media access control layer, this logical control layer, right? Suppose this is the one, only one, two devices are there, so there will be no issue whenever they send the data among them, right? Suppose, and let me bring back here, yeah. Suppose two more devices are there, and these devices wants to communicate like this, right? So like this they want to communicate, or like this they want to have communications, right? So whenever this kind of situation is there, so this is like in the air, so medium is the air here, right? If you consider like this, so you might not understand actually so how the accessing of the media is done. So for the better understanding, I'll better put the devices like this. So we are having 4 devices, and this is the medium and this is the time. Okay, so this is the time. Let it be this. Yeah, this is the time and this is the medium. For better understanding, I will keep this is the medium. Yeah, this is the medium, and these all guys has to use this medium in order to transmit the data. And somewhere here, some more or only one device is there. So everybody wants to send the data to here, or you can say I'll better put all these 3 so that it will be more clearer. Great. Yeah, and they have to use this one, correct? So what they do, they will send the data here, and they'll send the data here, and this guy also sends the data, and this guy also, this guy also sends the data, and this guy also. Oh, fine, this guy also sends the data, correct? And this here from medium to here, we the data, whatever the data has received from the respective device, and those respective devices data will be sent to the respective destination devices, right? So this is the time period. Great. So this usually will happen, right? So these 2 devices, if one device is send well and good, so no issue, it will go, right? No collision will be there. Suppose 2 devices are sending the data, so they have to use the same medium, so definitely there will be collision. And I'm assuming that okay, after certain time it will be sending, so it will send at time t1, and this guy will send at time t2, and this guy will send at time t3 and t4. So well and good, in this situation also no collision will be there. Suppose everybody will send at a time data, then there will be collision in the medium. As a result, all the packet will be lost or corrupted, right? And these devices will never receive those packet or the data or the informations, right? So for that, so before sending any data, I should know whether this medium is busy or idle, right? So to know this busy or idle, this mac, medium access control layer, will be used, right? So it has a many protocols: aloha, pure aloha, right? CSMA cd for the circuit, and we are having the CSMA ca for the wireless data transmission. Yes. So all the things will be declared in this media access control sublayer. Good. So the main functions. Yeah. So the main functions of the data link layer. The very first one is the framing. So whatever the data we will be, or the data link layer will be receiving from the network layer, so those data need to be put in a proper format, right? So here I said in the uh, uh, somewhere here something called the bitrate control, right? So the what is the exact the I mean the transmission rate or the actual capacity of the medium. Depending on that, we will be framing. So here we'll be having the maximum transmit unit. Depending on that, we will be framing the data, and that we call the framing. So this is depending upon the maximum transmission or transfer unit, whatever it is. So depending upon that, the frame size will be decided, and that we call the framing. And physical addressing, right? In order to uniquely identify the devices in a, so that we call the physical addressing, right? Or MAC addressing, we usually tell. And the third one is the error control, whatever the logical link layer, link control layer does. So that's also one of the function, so that we call the error control. And the fourth one is the flow control, right? So for example, the data rate must be constant on both the side, right? So this is the sender and this is the receiver, and whatever the data the sender is sending, that data, that data rate should be able to receive by the receiver. Okay. And if there is any mismatch between the sending rate of the sender and the receiving rate of the receiver, then whatever the extra receiver, for example, uh, sender rate is greater than receiver rate, right? So what will happen, the whatever the data will be there more than the whatever the capacity of the receiver rate capacity is there, so rest of the data will be lost, right? And again those data need to be retransmitted again back, so much delay will be there, right? So for that only we will do the flow control. So before sending any data, so both the entity need to be have a clear understanding about the rate, sending rate and the receiving rate. So that we call the flow control. And the last one is the access control, right? Medium access control, which I have explained in this figure, right? So whether the medium is busy or idle, so those kind of things need to be done in this layer, right? So in which devices this data link layer will be active. So the very first one is the switch, and the, so these are the networking devices where this DLL functionalities will be available. So this is about the complete data link layer. Okay. So now we will see the next one, third layer, called the network layer. Just highlighted. Fine. So so far we have seen the only this kind of a network. Correct. So only this kind of a network we have seen. Within the network, then we can easily send the data, so no issue. So what about if there is a what I can say, uh, two networks are there, so how to send the data from network A to network B, right? This is the network A, and one more network is there here, right? So one more network is there here, network B. This is the network A and this is the network B. Suppose this device wants to communicate with the device, right? So at that time we need the network layer concepts, right? So this network layer works for the transmission of data from one host to the other host which is located in the different networks, right? And it also takes care of packet routing and the packet routing, that is the selection of the shortest path to transmit the packet. So the first one is transmission of data from one network to another network. It's the first one. The second one is, in order to do this one, we need to do the routing, correct? So that we call the packet routing. That is the selection of shortest path to transmit the yeah, to transmit the packet. You can see to transmit the packet from the number of routes available. So n number of routes are available, in that the one particular route need to be selected, right? So yeah. And the third one is the addressing. So we call the IP addressing, to identify where exactly the host it is, right? So that will be done using the IP addressings, right? And this kind of functionalities will be there in the router, right? Devices, if you say so, this kind of functionalities we can see in the router. So this is the network layer, and and these are all, see, in the physical layer, the devices are hub, router, sorry, repeater and cables, and this is the modem, right? And in the data link layer, devices are switches and bridges, and the network layer devices router, right? So all are the physical devices. So that's the reason here I have written these all three layers: physical layer, data link layer, and network layers are the hardware layers. Good. I hope you understood why the hardware layers I have written there. The fourth one is the transport layer. So the transport layer, so whatever the function it is done in the medium access control layer or the data link layer. So some of the functionalities will be repeated in the transport layer as well, right? And here we say that it provides the services to the application layer, or in the TCP IP model, if you see, it provides the services to the application, and here in OSI it provides the services to the session and the presentation layer, right? So here the data we call these segments. In this layer, the data is referred as segments. So it's a main uh, responsibility to provide the end-to-end segments in the, right? And here the main one function is, the first one is the segmentation. Whatever the data we will get it from the application layer, so this is the actual messages, whatever we type, right? So those are the actual messages, and using those messages we need to divide it, right? So divide it. So we call the or demux. So we need to divide the message into segments depending upon the maximum what we call MSS, maximum segment size. So depending upon the maximum segment size, we call the MSS. So we will be segmenting the messages, and this is done in at the sender side, and at the receiver side when it comes, so different MSS will come. So again we need to reassemble them, right? So that is the another functionalities of the transport layer, right? And the third one is the service port addressing. So in your laptop you might have opened the multiple tabs, right? And each tab gives the some informations. So in the transport layer perspective, so each tab is a one port. So one port address will be assigned to it, right? For example, the HTML, right? If you have opened the HTML file, so that is like a 80 is the port number for that, right? So similarly for the email, so Gmail, if you have opened one tab, so for that one port address, right? Or YouTube, if you have opened, like that is a HTTP, right? So for that one port addressing will be assigned, right? So all this responsibility will be taken care by the transport layer. And in the transport layer, it provides the two different services. Provides the two different services. So very first one is the connection oriented services. In the connection oriented service, like the way I have explained the uh, uh, what what we call that switching, circuit switching, right? So before any transmission of any data, we need to first establish the connection, then after that we have to send the data, and after sending the data we need to disconnect it, right? In the same way the connection oriented services also works in the same manner. The first one is the connection establishment, and the second one is the data transfer, and the third one is the termination or disconnection. So before two devices need to be communicated, before that they will do this three-way handshaking. We call three-way handshaking. One is the connection establishment, data transfer, and the terminations, right? And this type of transmission we call the reliable transmission, connection oriented services, because if any packet lost, or any packet corrupted, or any packet received with the error, so those packet recovery will be done by using the acknowledgement, right? Whatever the packet has lost, so that packet need to be retransmitted from the sender, and that can be done when the receiver sends an acknowledgement to the sender. And the second one is the connectionless services. So here for the connection oriented example is the TCP. And connectionless services, here only one phase is there. So in the above connection only three phases: establishment, transfer, and the disconnection, right? Here only one, just data transfer. So no connection establishment, no termination. Whenever you have the data, you just transmit that data. So there is no reliability in the data. So even though it is corrupted, you have to accept it, and the sender is not going to send an or retransmit a packet at these segments here. Here example is the UDP, user datagram protocol. Okay. And this layer, transport layer, is operated the operating system. Right. So this layer will be operated by the operating systems. So this is what today's class. Now it's almost 3:52. So I'll stop here. We'll continue the rest of the layers in the next class. So if anybody has any queries, please ask.